Geometric probability. Okay. So there's got to be a reason behind this, but whenever I teach this, whenever I hear those two words together, geometric probability, I immediately think of skydiving. I don't know if you guys have those kind of associations. Because I think skydiving, for example, that kind of ghetto picture up on the board, the blue circle with the gray square, rectangle, sorry. It's like we're skydiving. We literally are looking and we're about to land somewhere, right? Well, the blue would be like shark-filled water, and the gray is where we want to land. So we've got to figure out what are our chances that we're not going to land in the shark water, we're going to land on the gray. That's geometric probability. You've got two shapes. You want the probability of landing inside one of the shapes. Easy enough? Yeah? Okay, you've got two vocab words coming up. I left the nitty-gritty definitions. Feel free to write them down, and then let's talk about them. One first is probability. What's the first vocab? And we're going to extend that to geometric probability. Go for it, and then we'll talk about it. Okay, probability. Probability, really fun topic. The first vocab word, probability. Let's think of a really example. Okay, what's the probability of taking a fair coin and flipping heads? 50-50, right? Usually, with probability, people say percentage. So what percentage would that be? 50%. So what this is saying right here is probability is always from 0 to 1. People don't really think about that too much. And then it confuses my 7th graders when we do our probability unit. So you just said the chance of flipping heads, or tails is 50%, right? Do you know what decimal equivalent that is? There you go. That's where they get tricked. They don't realize that that just means 0.5. And then if you were to go to a simplified fraction, what fraction would it be? Okay, the thing about probability is any one of those answers is totally acceptable. Percentage is probably the most common. Usually it's answered in percentage. The next one, geometric probability. It's like I showed you before on the parachute problem. You've got a shape inside a shape, and you're trying to find the probability of landing on one part of the shape. We'll get into that more later in the notes. There's examples. Okay, the first part, the theorems. Here we go. Okay, so this is asking, if you don't feel like reading it, it's saying, we'll pretend, what are the chances, what's the probability that I have a dart in my hand, and I huck it at the board, and it lands, and it sticks somewhere like right here. Right here is where I want it to land. To find the probability of landing, you take what you want, and you divide it by everything, the total right here. So we want it to land on CD, but the probability is that over everything. Okay, you ready to put some numbers in there in practice? Let's just make them up. So what if AC is 8, CD is 4, DB is 3? Can you find this? The probability that we huck the dart and it lands on CD. Think, where do you want it? We want it on CD, so how much is CD worth? 4, right? Over what's the entire thing worth? Perfect. Okay, change it. Change it to a decimal, change it to a fraction. All right, do you know what to do? All you do to change this to a decimal is what? Yes, just divide. That line means divide. So 4 divided by 15. Okay, another thing, we really hit fractions, decimals, percentage hard in the 7th grade. So the safest way is to always round to hundredths. Do you know how many spots after the decimal is the hundredths? 2. So round to the hundredths. What is it? 0.27. There you go. Be careful. It's 0.27, right? That's the decimal. What's the percentage then? It's 27%. Let me show you why I teach my 7th graders, because it makes us laugh, and then they remember. They have a hard time, well, they used to have a hard time going from decimal to percent, because they would bounce it once and say it's 2.7. So I said, nope, don't bounce it once. You got to bounce it twice and make a butt. Nobody wants half a butt. When you bounce it once, that's half a butt. Bounce it twice, you always bounce it twice, whole butt, 27%. It's silly, but it makes them remember. Okay, got it? Next one. This is the geometric probability. This is what's the probability that we hug something, it lands right here. So we take what we want there and what we want over the entire thing. Let's not put something in here because it comes up on later in the notes. Are you okay with that? All right, you ready? Next one. I like the number line one. Bad. So find the probability that a point chosen at random on PQ is on RS. You know what? Let me give you time. Try this one on your own. Okay, first question, how long is the entire thing? All right, 20. Does that go in the numerator or the denominator? All right, denominator, I'm going to put it right here. Numerator is where we want it to land. How big is the space where we want it to land? 6, are you sure?
Yeah.
All right, 6 out of 20. Right here, put your fraction answer, and then decimal answer, and then percentage answer. So simplify 6/20ths. What is it? What is it? As a fraction. There you go. 3/10, and then it's what? 0.3 for the decimal. Okay, be careful. Common mistake the 7th graders will say is 3%. They only bounce at half, right? Half of a, what is it really? 30%. Bounce it twice, put a 0 in the blank, 30%. I feel pretty okay about number ones. Feel okay about those ones? Okay, let's see what's next. This one blows my mind. I think golf is, once you see the probability, this sport is amazing. All right, here we go. So what we're trying to find the probability is we're amazing golfers and we can get it right in that cup. Compared to just the green, not the whole course, just the green. There's one thing that might trick you if you just start. Look at the picture. The radius of the cup is what? Inches, right? Then look at the radius of the green. You gotta change them. So we've either got to change this to inches or this to feet. What do you want to do? Don't you think changing feet to inches will go faster? Okay, so let's change this 30 feet to inches. It's times by 12. Grab your calculators or do it in your head. Just do 3 times 12 out of 0. Is it just 360 inches? Okay, where do we want the golf ball to go? In the cup. So that's going to be numerator. Numerator is what we want. So the cup, it can be anywhere in the cup, right? We got to find the area. So the entire circle. Do you remember area formula though? Perfect. If you want to sneak it in your notes, area formula of the circle is pi r squared. So area of the cup is the numerator. All right, let's be nice to ourselves and let's just write it like this. I'm going to put 2.125 squared pi. Let's not worry about a decimal equivalent right now. I think something will happen. Yes. Okay, area of the green, we just said the radius is 360 inches. Let's do the exact same thing. Let's just do 360 squared pi for the denominator. What we want over the entire circle. Oh no, the squares don't cancel each other out, but something else cancels out. What? The pi cancels out. So nice. So these are gone. So if it was my calculator, I would probably do this. We've got the square button on there, right? So I would type in parentheses 2.125 squared divided by, in parentheses, 360 squared. Parentheses may be unnecessary. I just am nervous. Sorry, calculators. This is a ridiculous answer. It's tiny, right? How many zeros after the decimal? I forgot. Okay, I'm going to write it like this. So 0.1, 2, 3, 4, like that? Yeah? Okay, then what's the percentage if I ask for the percent? Take it, right? And bounce it how many times? Twice. Boing, boing. So the percentage is 0.0034%. Guys, does that blow your mind? It's amazing. The chances are so slim. It's amazing. Ugh, I think it's way cooler than you do. Flip the page, flip the page. All right, heads up. I think that these problems are fine and you guys will be okay, but always watch out. Sometimes some dork making the number line doesn't start at 0. That doesn't ever make sense to me, but just watch out for that. In case it doesn't start out at 0, you'd have to adjust a little bit. This one does, so go ahead, try number 1. You'll be okay. Try it, try it. 36 for the numerator?
No, 24.
All right, 24 for the numerator. There's 24. Space in between. Now the denominator.
36.
Okay, do you know what that is as a simplified fraction? Yes. It's 5/9, isn't it? Oh, thank you. 20 over 36. There we go. That's definitely 5 minus 1.
Wait a second, how to 20? Because you can do 32 minus 12, which is 9, and then you get 20.
Perfect. I think it was counted by 4, so 4, 8. Yeah. Okay, so if I show you the trick with 9 in the denominator, 9 in the denominator is something to the numerator. Repeat it. So the decimal is 0.555, right? Dot, dot, dot. Guys, round that. Be careful. What is that rounded to the hundredths?
0.56.
Thank you. 0.56. So what percentage is it?
56.
Yeah. Be really good about rounding. What do I do? I got those. Even if they try to trick me with the number line, will we be okay? I just count it out. Okay, let's try another one. Oh, is this the trapezoid one? Okay, I've got a little hint bubble for you. I was worried that you would forget the formula. Does this look familiar?
Yeah.
Maybe you would have forgotten, but does it kind of look familiar? What does the H stand for? Do you know what the B's stand for? Okay, so let's talk about what we need to do. It says, find the probability a random chosen point in the figure lies in the shaded region. Ugh. Can we do the denominator first? The denominator is the whole thing. Do you agree with me? The whole thing is what shape? Okay, let's just do denominator first. Grab a color that'll show up. So denominator is the trapezoid formula. 1/2 times the height. What's height?
20.
Okay. Times in parentheses B1 plus B2. Does it matter which you use? B1, B2? No. What are they? Okay. Denominator. You know what? Are you okay if we just figure that out right now? Figure it out and we'll rewrite it. What's half of 20? 10? Do you know what 25 plus 18 is? Is it 43?
Yeah.
And then 43 times 10? That's not too bad. So denominator, the whole thing, there the whole thing is 430. Okay, here's where this is a perfect example of what's coming up on your assignment. You gotta think through this. We want the area of which part of the picture?
Circle. And then a diameter.
Reread the question.
Oh.
You said the circle.
You wanted the shaded region.
We want the shaded region. We do need the area of the circle. But if we want the shaded region, yes, move, yes. You take the trapezoid, you subtract the circle. That'll leave your outer. Does that make sense?
Is that the numerator?
Uh-huh. What we want is the trapezoid without the circle. So let's take our trapezoid answer, 430, and subtract the area of the circle. And that'll give us what we want. That'll give us the leftover on the edges. Area of the circle, do you remember the formula?
Pi r.
Perfect. Area is pi r squared. But in this case, what's r?
10.
Yes! So let's do minus pi times 10 squared. Well, guys, what is 10 squared?
100.
Yep. So in my calculator, is it?
Because you move it over 2 places.
Maybe stick in some parentheses. So your calculator doesn't just do 100 pi divided by 430. It does the whole numerator divided by 430. Oh, I don't have pi on my calculator. Can I just get the decimal first? Well, is it a decimal? It's gotta be. We've got pi in there. Go ahead, Abigail, thanks. 150.8? 115.8? Nice. Boy, that doesn't make any sense for probability. Oh, so that's the numerator? And then divide by 430? Got it. It's got to be around like 25%. 27? All right. Okay, so how many of you got that one? Did you follow the reasoning behind it? That's more what I'm concerned about. The process of it. Okay, one more. I like this one. I did that. Okay, so this question is saying, you have a friend coming to visit you between what time and what time? 3 to 5. However, you have to do what before they visit you? Clean your room. How long does it take you to clean your room? 20 minutes. Okay. So what is the probability that your friend will arrive while you are cleaning your room? Dun, dun, dun. Okay, so you have 3 to 5 when the friend's coming to visit. Okay, so how many minutes is 3 to 5? How many? 120, because it's 60 and 60. Is the 120 your numerator or denominator?
Denominator.
Yep, because that's the total time. What goes in the numerator then?
20.
20, right? Because it takes 20 minutes to clean your room. So that's just 2 over 12, 1 over 6. I think I have this memorized from our probability unit in 7th grade. Check your calculators, make sure I do this right. I swear it's 0.1666666.
Yeah.
So that would just be 0.17, right? Yeah. So what percentage?
17.
There we go. Will you be okay with those ones?
Yeah.
Make sure you do minutes and minutes. Okay, perfect.